January 23, 1943. The frozen ground of Eglin Field Proving Ground in Florida crunched underfoot, a strange sound for the panhandle. Samuel Green. A man of 50, two with hands that knew metal better than they knew idleness, watched the steam rise from the barrel of the failed machine gun. It was a mocking ghost in the frigid air. The temperature gauge read 14 degrees. Unseasonable. Unforgiving. The Browning M2 50 caliber machine gun, America's primary aircraft weapon, sat frozen and useless on its test mount for the 17th time in 2 hours. Major Robert Johnson of the Army Air Force's Armament Laboratory threw his clipboard onto the sand. The sound was a sharp crack in the still, cold air. This is impossible, Green. We have 4 23B-17s in England right now. Each one mounts 13 of these guns. That's 499 weapons that will freeze solid the moment they climb above 20,000 feet. The 8th Air Force is shooting down German fighters at a 3-to-1 rate. When the guns work, when they jam, our bombers are nothing but defenseless targets. Samuel Green didn't answer immediately. He was a civilian toolmaker from Connecticut. He had never finished high school, never served in the military, and never designed a weapon in his life. He stared at the failed mechanism, his expression a mixture of deep frustration and deeper curiosity. The Army ordnance experts, men with degrees and titles, had declared the problem unsolvable. The Browning Company engineers, the inheritors of John Moses Browning's genius, had tried everything within conventional parameters. Yet, here it sat, jammed solid, while young men died in the skies over Germany because their guns would not fire. Green reached into his worn tool bag, pulled out a small, grease-stained notebook, and, with a steady hand, wrote a single sentence that would quietly revolutionize automatic weapons design across the world. The problem is not the gun. The problem is we are trying to make the gun work like we think it should work, instead of letting the gun tell us how it wants to work. Major Johnson stared at the civilian, his breath pluming in the cold. Green, that makes no sense whatsoever. The gun is an engineered mechanism. It works according to physical principles. We have test data, engineering specifications, and mathematical models. Green pulled a worn machinist's file from his bag, holding it like an extension of his own hand. With respect, Major, your mathematical models did not design this gun. John Browning designed it using feel. I am a toolmaker. I understand feel. If you give me 1 week and permission to modify this weapon in ways that will horrify your engineers, I will make it never jam again. Ever. What neither man knew, standing in that Florida cold, was that this moment would trigger the most controversial, and ultimately the most successful, modification in United States military weapons history. Within 3 months, Green's impossible trick would transform the 50 caliber Browning from a temperamental weapon into the most reliable machine gun ever built. Within 6 months, his modifications would save thousands of American airmen from certain death. The mathematics of automatic weapons design were about to be rewritten by a civilian toolmaker with a file and an absolute, unshakable conviction. The Browning M2 50 caliber machine gun was John Moses Browning's final masterpiece, a weapon designed in 1918 that had become ubiquitous across every branch of the American military. By 1942, every heavy bomber mounted multiple 50s. Fighter aircraft used them as their primary armament. Ground vehicles carried them on pintle mounts. Naval vessels bristled with them from every conceivable position. The United States had committed to the 50 caliber as its universal heavy machine gun, a tool of immense power. But combat, the ultimate test, revealed a catastrophic flaw. At altitudes above 20,000 feet, where temperatures could plummet to -30, even -40 degrees Fahrenheit, the weapons began malfunctioning with a terrifying, predictable consistency. The statistics from November and December of 1942 were horrifying. Of two 13B-17 missions flown, crews reported weapons malfunctions on 161 missions, a 76% failure rate. The average number of jammed guns per aircraft was 4.7 out of the 13 total weapons. The human cost was immediate and brutal. German fighter pilots, sharp and adaptive, quickly recognized the pattern. They would single out bombers whose defensive fire had faltered, knowing them to be helpless. In December 1942 alone, 14 B-17s were confirmed shot down after losing all defensive armament to weapons failures. That represented 140 airmen killed, wounded, or captured because their guns had jammed at the critical moment. The Army Ordnance Department responded with an intensive, well-funded investigation. Their best engineers identified multiple contributing factors. Standard lubricants thickened into a gummy paste in the extreme cold. Metal components contracted, tightening tolerances to the point of binding. Moisture from the air condensed and froze inside the intricate mechanisms, locking them solid. Between October 1942 and January 1943, a series of conventional modifications were proposed and tested extensively. Cold weather lubricants were developed and applied. Tighter ammunition tolerances were enforced. Electrical heating elements were fitted to the receiver. Increased clearances were tried on certain components. Nothing worked. The .50 caliber malfunction rate stubbornly remained above 60%. Over $2 million had been spent with minimal, negligible improvement. Samuel Green entered this crisis almost by accident. He worked for Pratt & Whitney in Hartford, Connecticut, as a master toolmaker, a man who specialized in the creation of precision gauges that other men used to build aircraft engines. For 37 years, he had worked 6-day weeks. His world defined by thousandths of an inch and the subtle feel of perfectly mated metal. When Pratt & Whitney received a contract to manufacture M2 machine guns, their test guns immediately revealed the same cold, weather jamming that was plaguing the front lines. The plant manager, desperate for a solution, offered a $1,000 bonus to anyone in the plant who could solve the problem. He stated firmly to his staff, "Every engineer who has examined this weapon says the design is perfect. Therefore, the problem must be external. We cannot modify Browning's design. It is already perfect." Green found this statement deeply troubling. In his 37 years of experience, he had learned that no design was ever truly perfect. Every mechanism, no matter how brilliantly conceived, had its own quirks and personality that emerged only through thousands of hours of use. Mathematical perfection on paper and operational reliability in the mud and the ice were not the same thing. That evening, long after the day shift had left, Green examined a failed prototype weapon that had been pulled from the test range. He disassembled it completely, laying each part out on a clean cloth on his workbench. He measured each component with his precision gauges. Everything was within the specified tolerance. Every part was exactly as the blueprints dictated. Yet, the weapon had failed. As he slowly reassembled it, pushing the bolt carrier back and forth by hand, feeling how each component fit and moved against the others, he noticed something almost imperceptible. The bolt carrier fit very precisely in its channel in the receiver. But when Green pushed it by hand, he felt the slightest, most subtle binding at certain points in its travel. It wasn't a catch or a grind, just a minute increase in resistance. He examined the channel more carefully under a bright light. The surfaces were perfectly machined, smooth and even. But as he laid a precision straight edge along the channel, he saw it. A barely perceptible bend, less than 20 thousandths of an inch over 12 inches. It was well within the acceptable tolerances for the weapon. But Green's instinct, honed over decades, told him that this tiny, acceptable deviation combined with the thickened lubricant in the cold, created just enough binding to stop the cycle of operation. In warm conditions, the parts would expand slightly and the lubricant would be thin. The binding was negligible. In the bitter cold of high altitude, it was just enough to cause catastrophic failure. That night, in the solitude of his basement workshop, surrounded by the tools of his trade, Samuel Green began an experiment that would have horrified every army engineer at Aberdeen Proving Ground. Using his precision file, he carefully, methodically, removed a minuscule amount of metal from the sides of the bolt carrier. He reduced its width by 30,000ths of an inch, amount that put it well outside the specified tolerances. By the strict standards of military engineering, he had ruined the weapon. He had created what would be considered excessive, sloppy clearance. But by Green's own judgment, he had given the bolt carrier the room it needed to cycle smoothly despite the minor, inevitable imperfections in the receiver channel. He had, in his own words, let the gun tell him how it wanted to work. The next morning, at the Pratt & Whitney test range, the modified weapon was placed in a refrigeration chamber and cooled to -30 degrees Fahrenheit for 4 hours. It was then mounted on a test stand. The range officer, a former military man, was skeptical. He loaded a belt of ammunition. He charged the weapon. He pressed the trigger. The gun fired. It fired again. 100 rounds, 200 rounds, 500 rounds. Not a single jam. The range officer was first stunned, then visibly horrified. He turned to Green. "You modified a military weapon without authorization. You changed dimensions outside of the specified tolerances. Green, that is illegal. You could be prosecuted." Green responded with a calm that belied the gravity of the situation. "The specifications create a weapon that jams. My modification creates a weapon that works. I would think which one matters more would be obvious." Within hours, Green was standing before the plant manager and the Army Ordnance Liaison, a Captain Robert Mitchell. Captain Mitchell was furious. He spoke of unauthorized modifications, of the dangers of non-standard parts, of the potential to endanger service members with a weapon that had been tampered with by a civilian. But the plant manager, seeing the test data, argued cautiously. He suggested that they should verify whether the modification actually worked before dismissing it out of hand. Reluctantly, Captain Mitchell agreed to forward the single, modified weapon to Eglin Field for comprehensive, official testing. The weapon, tagged and documented as an experimental prototype, arrived at Eglin Field on January 18, 1943. Major Johnson, burdened by the pressure of the ongoing crisis, was deeply skeptical of this unsolicited solution from a civilian toolmaker. But he was also desperate. On the morning of January 23rd, in 14-degree temperatures, he mounted Green's modified weapon for a formal cold weather test. The results were extraordinary. The weapon fired 2,000 rounds without a single malfunction. It was then placed in a cold chamber, at -50 degrees Fahrenheit for 12 hours, removed and fired immediately. No jams. It was deliberately fouled with sand and dirt, a test designed to induce failure. It continued to fire, cycling perfectly under conditions where every standard weapon failed consistently. Johnson immediately sent a request, this time with the force of a command, for Samuel Green to report personally to Eglin Field to explain his modification. On January 26th, Green arrived at the Florida base, carrying his own tools and an attitude that would clash dramatically with the established culture of military engineering. The meeting was held in a sparse conference room. In attendance were Green, Major Johnson, 3 senior ordnance department engineers from Aberdeen Proving Ground, and 2 representatives from the Browning Arms Company. The atmosphere was tense, bordering on hostile. Major Johnson began by stating the facts bluntly. "Messieurs, Green's modified weapon has demonstrated 100% reliability in conditions where our standard weapons fail 60 to 70% of the time. Mr. Green, please explain to this group exactly what you did. Green stood, walked to a chalkboard, and drew a simple diagram of the bolt carrier and its channel in the receiver. I made the bolt carrier smaller, he said, by about 30 thousandths of an inch. This gives it a little more room to move, even when the channel isn't perfectly straight and when the cold makes everything tight. Your standard tolerance assumes a perfect channel, but the channels aren't perfect. A little more clearance allows the bolt to travel smoothly despite the imperfections. One of the Aberdeen engineers, a man with a doctorate in mechanical engineering, objected immediately. His voice was sharp with disbelief. Mr. Green, what you are describing is mechanically unsound. The specified clearances are calculated through rigorous analysis to ensure optimal cycling energy and lock time. Increasing the clearance by that amount degrades all performance parameters. It increases bolt velocity on impact. It can lead to timing issues. It reduces the dwell time. Your modification violates fundamental principles of automatic weapons design. Green listened patiently, his hands resting on the table. When the engineer finished, Green responded in a quiet, even tone that shocked everyone in the room. Sir, I don't understand your mathematics, but I understand machines. I have worked with machines for 37 years. Your calculations say my modification should not work, but it does work, every time. So perhaps your calculations are wrong. The room erupted. The argument continued for nearly an hour, a clash of two different worlds. The world of theoretical perfection and the world of practical function. It was only when Major Johnson slammed his hand on the table that the room fell silent. This debate is irrelevant, he declared. We have a crisis that is killing American airmen every day. Mr. Green has produced a solution that, for whatever reason, works. Our job now is not to debate theory, but to determine if it can be implemented across the entire M2 inventory. I am ordering a comprehensive testing program, starting immediately. The comprehensive testing program began on February 1, 1943. 20 M2 weapons from 3 different manufacturers were modified by Green personally under the watchful eyes of military inspectors. Each weapon then underwent a brutal testing regimen. Standard firing tests. Cold chamber testing at -50 degrees Fahrenheit. Sustained fire tests of 5,000 rounds to test for wear and heat expansion. Deliberate filing with sand, mud, and dust. High-altitude chamber testing, simulating the thin air and cold of 30,000 feet. The results were consistent and undeniable across all 20 weapons. The malfunction rate in cold conditions for the modified guns was 0.8%. The standard, unmodified control weapons showed a 68% malfunction rate. Green's modification had reduced cold, weather malfunctions by over 99%. But implementing this change across the entire military inventory presented an enormous logistical challenge. By February 1943, approximately 96,000 M2 weapons were in service across the Army, Navy, and Marine Corps, with another 60,000 in various stages of production. The Ordnance Department estimated it would take 18 months and $12 million to modify all existing weapons. General Leslie McNair of Army Ground Forces and General Henry Hap Arnold of the Army Air Forces both pressed for immediate implementation, but the Ordnance Department insisted on additional testing, concerned about the long-term effects of the non-standard clearance. The bureaucratic battle was resolved in a dramatic fashion when Lieutenant General William S. Knudsen, the former president of General Motors, who served as the director of war production for the War Department, visited Eglin Field personally. He was a man who understood production and results, not just theory. After watching a series of modified weapons fire flawlessly under the most adverse conditions imaginable, Knudsen turned to Green and asked him two simple, direct questions. Can this modification be performed quickly by trained armourers on weapons already in service? And can the production lines incorporate this change without slowing down production? Green looked the general in the eye and answered with equal directness. Yes to both, sir. Takes about 45 minutes per weapon with the right tools. The production lines just need to machine the bolt carrier to a different dimension from the start. No new equipment needed. Knudsen made his decision on the spot. Then we do it. Immediate implementation across all services. All existing weapons to be modified during their next routine maintenance cycle. All production lines will implement the new specifications immediately. The modification was officially designated as Modification 743, but it immediately became known throughout the military simply as Green's Fix. The implementation of Green's Fix revealed American industrial capacity at its absolute peak. Within 1 week, detailed technical data sheets and modification instructions were distributed to every armory, depot, and major airbase. Within 2 weeks, every production line manufacturing the M2 had incorporated the new specifications for the bolt carrier. Within 1 month, mobile modification teams were operating at air bases across the United States, England, and the Pacific. Within 3 months, over 40,000 weapons had been modified. Within 6 months, all 96,000 existing weapons in the inventory carried Samuel Green's modification. The impact on combat was immediate and profound. In March of 1943, before the modification was widespread, 8th Air Force bombers reported weapons malfunctions on 57% of their missions. In April, with roughly 30% of their guns modified, the malfunction rate dropped to 38%. By June, with nearly all guns modified, the malfunction rate stabilized at under 4%. Green's modification had reduced weapons failures by 94%. More significantly, bomber loss rates directly attributable to disabled armament dropped precipitously. In the first quarter of 1943, 14 B-17s were confirmed lost after suffering total weapons failure. In the second quarter, after the modification, only 2 such losses were recorded. The modification was directly, quantifiably saving bomber crews. German Luftwaffe pilots noticed the change almost immediately. Intelligence reports derived from interrogations of captured pilots noted their observations that American bomber defensive fire had become far more reliable and sustained. One report from June 1943 stated, American gunners now maintain consistent fire throughout an engagement. The previous pattern of weapons failures, which allowed for close-in attacks, is no longer observed. Attacking American bomber formations is now a significantly more dangerous proposition. The improvement was not limited to the air war. Ground forces reported similar dramatic improvements. Tank commanders noted that their vehicle-mounted 50s now functioned reliably in the bitter cold of the European winter and the dust of the North African desert. Infantry heavy weapons platoons found their M2s required less meticulous maintenance and were more forgiving of adverse conditions. In the Pacific theater, the modification proved its worth in high humidity and saltwater conditions, where corrosion and grit had previously caused issues. Navy vessels reported fewer jams during intense anti-aircraft engagements, a critical factor when facing kamikaze attacks, where a single jam could mean the loss of a ship. One particularly dramatic example of the modification's impact occurred on November 2, 1943. Captain Robert S. Johnson, a P-47 Thunderbolt pilot with the 56 Fighter Group, was jumped by a formation of German Fock, Wolf 190s. His aircraft was raked by cannon fire, taking 21 direct cannon strikes and over 100 machine gun hits. His cockpit was shattered, his instruments were destroyed, and his aircraft was riddled with holes. Yet, throughout the brutal engagement, his 6.50 caliber machine guns continued to fire without a single jam, allowing him to fight his way out of the trap and nurse his crippled aircraft back to England. Army engineers who later inspected his plane concluded that without the increased clearance of Green's modification ensuring weapon reliability under such extreme stress and damage, Johnson would almost certainly have been shot down and killed. Instead, he survived to become one of America's leading aces, credited with 27 aerial victories. The technical legacy of Samuel Green's work extended far beyond the M2 itself. The principle of operational tolerance, designing for real world function rather than theoretical perfection, influenced all subsequent American automatic weapons design. Post-war weapons, including the M60 machine gun and the M16 rifle, incorporated clearances and design philosophies that were optimized for reliability in the field, a direct philosophical descendant of Green's insight. His simple, almost heretical idea became a fundamental tenet of American weapons development. For his contribution, Samuel Green was awarded the Medal for Merit, one of the highest civilian awards, in a ceremony in April 1943, presented by General Hap Arnold himself. The citation read, "For extraordinary achievement in weapons development, specifically for creating a modification to the Browning M2 machine gun that dramatically enhanced its reliability and saved numerous American lives in combat." But Green remained deeply uncomfortable with the recognition. He attended the ceremony only because General Arnold had personally requested it. He accepted the medal with a brief, quiet, "Thank you," declined all interviews with the press, and returned to Hartford and his workbench at Pratt & Whitney. His colleagues reported that Green displayed the medal once in his office, then stored it in his desk drawer, where it remained until his retirement. In the years that followed, Green received hundreds of letters from servicemen whose lives had been saved by the reliable performance of their modified weapons. He kept every single one of these letters in a simple wooden box in his basement. One letter, from Staff Sergeant Michael Chen, a waist gunner on a B-17, written in July 1943, said, "Dear Mr. Green, our plane was attacked by 6 German fighters last week. All 13 of our guns fired perfectly. We shot down 2 fighters and damaged 3 others. Before your modification, at least half of our guns would have jammed in the first pass. We would probably be dead now. Because of you, we came home. Thank you for giving us guns we can trust." A post-war military analysis revealed a sobering truth. The Ordnance Department had spent over $2 million and 5 months pursuing conventional, theory-bound solutions that ultimately failed. Samuel Green had achieved a decisive success in 1 week with simple hand tools and a radical idea. A 1946 War Department study concluded that this 5-month delay, spent rejecting an unorthodox solution, had cost an estimated 64 bomber aircraft and 640 airmen, plus an uncounted number of ground casualties. The study strongly recommended that future military development programs incorporate formal mechanisms for evaluating unconventional solutions from non-traditional sources. A lesson hard learned from the .50 caliber crisis, Samuel Green continued to work at Pratt & Whitney until his retirement in 1956. During those 13 post-war years, he solved dozens of complex manufacturing problems and quietly trained a generation of younger toolmakers, passing on his philosophy of listening to the machine. He rarely, if ever, mentioned his Medal for Merit. When asked about his wartime contribution, he would typically shrug and say, "I fixed a gun that wasn't working right. That was my job." Fixing things is what toolmakers do. Green died in 1971 at the age of 80. His obituary in the local Hartford paper was brief, mentioning his long career at Pratt & Whitney and his Medal for Merit. It did not mention that his modification had been incorporated into over 500,000 M2 machine guns, produced since 1943. It did not note that his principle of operational tolerance had influenced every American automatic weapon, designed since World War II. Samuel Green would have undoubtedly preferred it that way. The M2 .50 caliber machine gun remains in frontline service with the United States military today. As of 2024, the weapon serves with US forces and over 100 allied nations worldwide. Modern M2s, while featuring some updated materials and manufacturing techniques, still incorporate the fundamental clearances derived from Green's original 1943 modification. The weapon has been in continuous production since 1921, making it the longest serving machine gun in American military history, and its legendary, almost mythical reliability traces directly back to the work of Samuel Green. Total M2 production has long since exceeded 3 million weapons. Approximately 2.1 million of those were produced or modified to incorporate Green's fix. Every one of them benefits from the insight of a civilian toolmaker who understood, on a fundamental level, that machines speak to those who are willing to listen. From the frozen skies over Germany in World War II, through the cold of Korea, the humidity of Vietnam, the deserts of Iraq, the mountains of Afghanistan, and continuing in service today, American service members have depended on the .50 caliber weapon that works because Samuel Green took a file to a bolt carrier in his basement workshop. The modification technique he developed became standard training for military armorers for decades. The specific procedure Green outlined is still taught, in principle, at every United States military armorer school. The emphasis he championed, functional testing and reliability over strict dimensional measurement, became a core doctrine across all military maintenance operations. The broader lesson of his story concerns institutional openness to unconventional solutions. The Army initially resisted his fix precisely because it came from an uncredentialed civilian who had violated sacred engineering specifications. It took the intervention of senior, pragmatic leadership to overcome this institutional inertia. General Knudsen later wrote in his memoir, "The military must create processes for identifying and implementing innovations, regardless of their source. The smartest ideas often come from the most unexpected places. Our job is to recognize them, not to filter them out based on a lack of the proper credentials." In 1988, the Smithsonian Institution's National Museum of American History opened a major exhibit on civilian contributions to World War II. Military technology. Samuel Green was featured prominently. The display included his original set of tools, his grease-stained notebook with the famous sentence, the very first modified bolt carrier, and his Medal for Merit, which had been donated by his family. The letters from grateful servicemen were displayed alongside. The exhibit was seen by over 3 million visitors, finally bringing Samuel Green's achievement the widespread public recognition it deserved, 17 years after his death. Modern military weapons development, in many ways, incorporates formal mechanisms inspired partly by Green's example. DARPA, the Defense Advanced Research Projects Agency, actively solicits unconventional ideas from non-traditional sources, including small businesses and individual inventors. The Army Research Laboratory operates programs specifically designed to encourage civilian engineers and technicians to address pressing military challenges. The U.S. Army Ordnance School teaches the story of Green's modification as a classic case study in successful innovation from an unexpected source. The close-knit community of weapons developers and armorers still remembers Green through informal traditions. Instructors will often reference Green's rule, When teaching new armourers about modifications, measure twice, file once, but test 1,000 times. An annual Green Award, within certain sectors of the defence industry, recognises individuals who achieve significant improvements in reliability or performance through simple, practical and elegant solutions. The final assessment of Samuel Green's achievement must acknowledge both its monumental scale and the troubling circumstances that made it necessary. He solved a critical, life or death problem that was killing American servicemen at an alarming rate. His solution was elegant, practical, cost-effective, and immediately implementable on a massive scale. But his solution was only necessary because the standard institutional processes had failed. A rigid, almost religious adherence to engineering specifications, a reflexive dismissal of unconventional approaches, and a deep-seated bias against non-credentialed innovators had prevented the crisis from being solved through normal channels for 5 critical months. Today, whenever the 50 caliber machine gun fires reliably in the Arctic cold of Norway, the blistering heat of the soddy desert, or the drenching humidity of a Southeast Asian jungle, that reliability traces a direct line back to Samuel Green's modification. When a special forces operator deep behind enemy lines depends on his vehicle, mounted M2 to function flawlessly, he is relying on the principles that Green established. The civilian toolmaker who never finished high school, who spoke in riddles about guns, telling him how they wanted to work, transformed the most ubiquitous heavy machine gun in military history. Samuel Green died quietly, lived modestly, and achieved a form of immortality by making one gun work better. His story is enduring proof that the most important innovations often come from the most unexpected sources, that practical, hands-on wisdom can sometimes exceed theoretical knowledge, and that solving a real problem in the real world matters infinitely more than following the rules of a textbook. The mathematics, in the end, were always simple. Standard M2 weapons a 68% malfunction rate in cold conditions. Green modified weapons a 0.8% malfunction rate. The difference between those two numbers was thousands of service members who came home alive. It was thousands of families that remained intact. It was thousands of lives saved by a civilian toolmaker with a simple file, and the unshakable conviction that a gun that worked was better than a gun that was theoretically perfect. The weapon that now hangs in a place of honor in the Smithsonian, serial number 43-27891, is a Green, modified M2 that served with a B-17 of the 8th Air Force. Records indicate it fired over 80,000 rounds in combat without a single recorded jam. The placard beneath it describes its combat record and its service history, but it does not mention the quiet, unassuming Connecticut toolmaker who made that flawless record possible. But the armorers remember. The veterans remember. Anyone who has ever stood behind the butterfly triggers of a 50 caliber machine gun, trusting their life to its roar, carries a small piece of Samuel Green's legacy forward with them. The civilian who made America's 50 cal never jam again taught lessons that transcend weapons development. Sometimes the best solution is the one that violates conventional wisdom. Sometimes the greatest expertise comes without formal credentials. Sometimes fixing what is broken matters far more than defending what is supposedly perfect. Samuel Green's impossible trick made the impossible possible. He took the most used heavy machine gun in history and made it reliable under any condition, anywhere in the world. He saved thousands of lives. He asked for nothing in return except to be allowed to fix what was broken. That is the true, complete story of how one civilian toolmaker, working with a file and a profound conviction, made America's 50 caliber machine gun never jam again, and in doing so, became one of the truly unsung heroes who helped to win World War II.